Good evening, everyone. Hello, thank you. Good evening, everybody, and welcome to dev.talk. So let's get started with our first speaker, which is Kevin Ocansey, an AI engineer. Kevin is a data science and AI graduate and multiple hackathon winner with a passion for building intelligent systems, primarily using Python. And Kevin's going to talk about building an Agentic Mobile OS for privacy. So let's welcome Kevin.
Thank you. So without wasting too much time, I'm just going to go straight into it. I'm going to talk about JarvisOS, but before then, I'll try and talk about RAG and agentic systems to try and get us up to speed, as a refresher. So I'm sure by now, most of us know how LLMs work. So companies like OpenAI, Claude, and Gemini, basically what these systems do under the hood is just to predict tokens or predict words. Now, each model has a vocabulary. And the vocabulary basically are tokens. So if an AI wants to make a prediction, it goes through all the tokens and then it picks one. Now, these tokens, some of them are very special. Special tokens kind of dictate how the LLM would behave. So for example, if you see EOS, it means end of sentence. So if the model sees EOS token, it stops predicting any more tokens or any more words. Sorry, I'm Russian. I have a lot to talk about, so I'm trying to get up to speed. So this, with special tokens, it gives like an agentic behavior. And aside the agentic behavior, we need things like RAG, because most LLMs are trained on huge amounts of data, and they are not aware of any new information that's out there. So with that agentic behavior, we are able to give them tools which they can use to interact with an environment. And you pair that with something like a React framework, which kind of tells the LLM. So basically, if you give an LLM a task, right, it's able to observe itself doing the task, and then it's able to figure out if I'm actually getting towards the goal or if I'm drifting off. And then it gives that flexibility. Another form of RAG is vector databases. And the way vectors are basically how LLMs see information. So it's kind of like coordinates in high dimensional space. And they are basically numerical representations of information. So the relationship between words can be represented as vectors. So with these type of databases, the way RAG works is that when you send an LLM a query, it goes into the database and tries to find any document which is kind of similar to the query that you've provided. And then it retrieves that information and passes it off to the LLM to then make its prediction or to, make inference. Now, RAG has developed over the years. Now it supports not just text. We have multimodal RAGs where the LLMs have power to work with text, sound, images, videos. I think Gemini is one of the most powerful ones when it comes to video streams. I don't know if any of you have used Notebook LLM. It's really good because it can help generate podcasts based on, information that it has access to. Okay, so we've covered a lot. And basically all of these are the building blocks of this agentic systems. These are some top 5 agentic frameworks that you should know. We have LangChain, which basically gives you a suite of models that you can pick from. And then it also gives you access to tools and vector databases. LangGraph builds on this by providing, state management, control flows, etc. QAI is really helpful if you want multiple agents to kind of collaborate on a task. And then we have the different Microsoft frameworks that help you integrate that into the Microsoft ecosystem. If you don't want to build your agentic system, what you can do is you can use services that already have these set up in the background. So you can use Cursor or Lovable if you are coding. So that's why you have coding agents to assist you with, your projects. And then Zephyr Edge is for automating web tasks. So before Claude Cowork, this was what I was using to help me figure out things online. And then we have Bland AI, which helps you automate calls. So if you want your agents to call someone, retrieve all that information from the person, and save that in a database, you can use something like Bland AI. And we have Future House as well. So let me make a distinction between Zephyr Edge and Bland AI. So for example, I talked about tools and I talked about vector databases. So tools would be really helpful with Zephyr Edge because the agents would need to open a browser, click certain parts of the page, do a lot of interactivity. Whereas with Bland AI, you probably need more vector databases because you want to store context. You want to store information about who you are calling or what the agent calling needs to talk about. Hope that makes sense. Great. OK, now I can slow down. So the point of this talk is about mobile OS. Why mobile OS? Why mobile agentic OS? There's a shift happening in the AI world. The thing is, AI is very expensive, right? Most people pay for tokens, or most people pay for the infrastructure so that they can host their own LLMs and then run everything locally. So that's a clear distinction. But there are more people that are opting for that local agentic behavior so that they don't have to pay for tokens. All they have to do is pay for electricity or power, right? Now, that's for people who have money to invest in GPUs and all the infrastructure that makes AI run normally. But we are also seeing a shift in chips and hardware that can support smaller versions of these big models. And we're also seeing a lot with mobile. There's a lot of investment in the new chips that are coming out in the latest phones. For example, Apple is making a lot of investments in their Bionic chip. We're also seeing Qualcomm make a lot of investments in Snapdragons. And NVIDIA, of course, is always making the news. Now, we've talked about the hardware, but aside the hardware and the improvements in the hardware, we also have the software also growing, frameworks that can support local agentic systems. How many of you know about Ollama? OK, perfect. So Ollama is really good to help you download these models on your PC. And it gives you LLMs, right? But you usually have to pair that with another framework, maybe LangGraph, to give you that agentic behavior or memory so that the LLMs can use on a daily basis. Cactus, how many of you have heard of Cactus? OK, perfect. Some. So Cactus, think of Cactus like Ollama, but for your mobile phone, right? And Cactus gives you, it supports a few LLMs like Quen, I think Liquid, and then Whisper. And what we are trying to do, Sam is one of my teammates, what we are trying to do is build something like LangGraph to support that agentic behavior with Cactus. Hope that makes sense. The thing that sets Cactus apart is the ability to compress these large language models to be able to run on your phone. So naturally, large language models store their weights in full precision floating point numbers. So these can look like 13 points, blah, blah, blah. And these floating point decimals are really long. And each weight stored can take, it takes 32 bits, so that's like 4 bytes. Quantization is a way to reduce these bits so that it takes half. So you can convert from FP32 to FP16 and then to int8. So basically, you are reducing the size of the models by half and by a quarter. The pros and cons with this is that you get speed, but you may not get accuracy. And this is a very, very important technique or idea. We are also seeing a lot of research going into how to make models very, very efficient. So today, I saw that Google released something called TurboQuant, which is kind of making this more efficient, but getting the accuracy. So it's retaining the accuracy. So although you're able to reduce the, what's the name? The numbers, you're able to scale it back so that you keep the accuracy. Yeah, this is basically how it looks like. So this is an embedding of the text, set an alarm for 7 a.m. So this is how the model will see that sentence, right? And then these are how the floating point numbers look like. So when you quantize them, something like negative 0.6 could be reduced just to save space. Recently, Google released function, I think that was last year. So let me tell you a bit about how the idea of Jarvis came about. Last year during a hackathon, Sam and I got to hear of Cactus. It was a hackathon for AI, and we were interested in the idea of running these models on your mobile phone without the internet. And the plan was we built a simple app, right, which could run the model Quen, at that time, offline. And then we were able to build the app in, I think, a week or so. So then we decided, what can we do? What else can we do to really sell an idea? And then we decided that how about we have something that controls every single thing autonomously, that works in the background or your mobile phone. We started planning that out, and then the next month, Google released Function Gemma. So it tells you that this is kind of where the industry is probably heading to. And it was really, really, it gave us like some motivation to actually see it through, because it feels like we are actually on something, and it's kind of like we are preparing for what the world might. It's kind of like we are meeting, yeah, basically. Anyway, so Function Gemma is a really small model. It's 270 million parameters. It doesn't take a lot of space, but the downside is that it's not the sharpest tool in the shed. So at that point, we tried to make it the only model on the phone or the app so that you can have conversations with it. a simple hello, and it just went off the rails. So it tells you that you can't rely on it. I mean, it wasn't built for that conversation, that element. It was built more for tool calling, which is a very, very important thing in that agentic behavior. Then I think a few months later, we're still working on Jarvis, and then we saw Cactus was holding another hackathon, and this time it was purposely for Function Gemma, because they kind of were trying to integrate Function Gemma into their suite of models, and they realized that it's not the best model, but obviously it's for tool calling. So they held a hackathon where we come together and we try and make Function Gemma really, really good in picking tools. We went to the hackathon in London. It wasn't the best because I sent a Windows machine to a Mac fight. Basically, it was for Mac users. But the team did amazing. They were able to approach the problem in a really smart way. So we're going to be judged on two things. Accuracy, that is, Function Gemma is able to pick the right tool given a task, and then also speed. Now, with something like that, let me try and break it down. So basically, task, right, can be broken down into 4 categories. So it could be one intent. So basically, you are telling the model, text Sarah. It could be multiple intents. So maybe you are telling the model, text Sarah, and when she replies, do something else. And it could be parallel intents, where it's like you have 2 different things that you want the model to do, but you don't want it to do it at the same time, or one depends on the other. And then you can also have no intent as well, which is the model should know that I do not need a tool for this task. So we are able to finish the hackathon with, I think, 67 or 70%. The people who were first was 80-something, which was really good. But basically, what I'm trying to say is there are various ways you can approach this problem. And I want to show you how various ideas can result in different behaviors. So this particular function, what it basically does is that you send a query to the model, and it would return the top K tools. Another approach could be you send a query or a task to the model, and it's able to send you the tools that it has 0.6, more than 0.6 confidence in. So there's a huge difference between the first one and the second one. So the first one is dependent on K. So if you change K, you get different results. The second one is dependent on the confidence the model has in the tool. And the last one is you have the same threshold, but you want a minimum gap in the tools. So basically, if the model has confidence in 3 tools with 0.6 and above, and the next one is 0.5, that's a huge gap. So it drops that last one. So for attacks like check the weather in London and text Sarah it's cold, the first one, getting 2, would pick gets weather and gets calendar based on the first 2. So obviously it did a mistake because it's supposed to get weather and send message. With the threshold, looking at the confidence score, it picked 3 tools when the tag just needed 2. With the threshold gap, it picked just 1. So there are still some ideas, different ways to solve it, but that's the whole goal. But after the hackathon, we realized that the best way to make Gemma really, really good is zero-shot prompting. So that means that do not give it any prompts, no prompt engineering. What you should focus on more is the description of your tools so that it can match the query to what the tools need. So that brings me to JarvisOS. So JarvisOS is an idea where you have maximum control over everything, basically. So imagine you want your phone to do something for you. You can just put earbuds in and talk to it, and it can ask you questions, and then it can figure it out on its own. So to do that, we need a core understanding of the Android operating system and the different layers in it. At the application level, we've been there. We've been able to create an app. But now we are going down to the systems level. The Android framework basically exposes all the background services to the application level. And then we have the hardware abstraction layer, and we have the kernel. That's the lower you go, the more metal you get to. The system services basically has things like the notification, location. So basically, apps like Maps, Uber can get information from the systems level. So that's where we are currently exploring and trying to figure out how much control we can give to our LLMs. So this is how the architecture will look like. We've already copied Lineage OS, which is for Nothing Phone, but we may change to Pixel. It still runs with Pixel. We are going to give Jarvis as much permissions as it needs. We've used Cactus on the app level, but now we are going to use it at the systems level. And then we are going to change or edit some controls in the background services, like File Observer, Work Manager, because we need to make sure that we are not running. I'll get to the challenges later. So how do we want the brain of Jarvis to look like? So Cactus will manage a lot of the things, right, under the hood, but we want to add a new vector database on top of Cactus so that we don't, because with RAG, you need to do a lot of embeddings, okay? And that takes time. So you want like an indexer before Cactus. So the model kinds of learns about metadata. It learns about how the user behaves before it does any RAG. So this is how it will look like. So we've planned to make sure that we can have things happening in the background where the user is not aware. And then when you plug in your phone, where you have more power, then we can do more tasks. So Cactus will handle indexing and storing embeddings, like the numerical representations of data directly. And then Objectbox would handle both numerical, like vectors, but also it can handle normal JSON storage. To ensure that the Jarvis has power over, so if you have two apps that want to talk to each other, for example, you tell Jarvis to do something in Calendar and then text Sarah, you need to get information from Calendar and then send that over to, let's say, WhatsApp or something. We are going to use binder IPC, which is kind of like how Android, the normal processes work, where apps can talk to each other. Also, because of how we are architecturing this, it means that there has to be a lot of changes in how we design mobile applications. So mobile applications are going to be agentic already, but I think currently how they work with agents is through MCPs, and that's over the internet. So you need a client and you need a server. But because we want everything to be local, everything to be native, we are trying to figure out how we can make the app announce to Jarvis that these are the tools that I have and what I can do automatically. Android supports that, but we also need to register them so that Jarvis is aware of all the tools for different applications. So once you have installed an app, it announces to Jarvis that with the broadcast that these are the tools that I have. So that's one, it's a broadcast. And then you have the binder IPC, which is like a receiver, which is like an open channel, right? Where there's constant, so it's opened. So Jarvis can connect to the app, do everything it needs to do, and close it. The challenges we're having so far, where do I start? It's overwhelming. It's an overwhelming project. There's not a lot of experience with Android itself, so we have to figure that out as we go. We also need to test. Because we are making a lot of changes, we can't run it normally on an emulator. We need to actually get a phone and boot it and test it. What else? I think the memory itself may be challenging because every file would need a duplicate like a vector version of it so that the model can handle it. And what we are planning on doing is making Jarvis aware of its own self so that it can delete certain things that it doesn't need. We also know there'll be a lot of challenges on battery itself. So the thing is, basically, we are doing it in phases. So we want to get the phone, test it, and then we will figure out everything else. So what are the use cases for this? Because why wouldn't you just use OpenClaw or have remote sessions where you can just text everything to an agent sitting somewhere else? Well, the first thing is privacy. You want something that the data doesn't leave your phone. It's stuck on your phone. And also, I think generally it pushes the boundary on small local LLMs. So basically, we are making LLMs more efficient. If it can run on your phone, that means it can run on microcontrollers. It can be very, very efficient with little systems. The truth is, like, on-device AI is not new, right? It already exists. We have deep learning models that are connected to traffic lights that help you regulate traffic, object detection drones as well. And what LLMs just brings to that whole ecosystem is that interactivity where you can actually talk to it and you can get a response. So imagine you're in a factory and the robot is able to talk to you. Let's say you're doing something and it gives you advice that do it this way. Or let's say you are stuck in the forest somewhere and you have like a mini map that can guide you. Sorry, it's really bad examples, but I think that's also a challenge, is like figuring out what the use cases will be, because I feel like those can guide like the whole architecture. But yeah, and IoT devices as well. So smart homes can benefit from something like this, where everything is kind of connected, but segregated. So you can have Jarvis on each device. They share information, not raw data. What else? Also, I didn't talk about, so there's something called federated learning. So with private systems can accumulate a lot of data. But because it's private and you don't want to share it with a server somewhere, federated learning helps you update the models on those devices without actually interacting with the data itself, which I think is really, really helpful. So in case you want to update Jarvis, make it more smarter, but obviously because of privacy concerns, you don't want to access the data. And recently, there was a paper that was released that could also increase the efficiency. So I've already said that tokens are predicted one by one, but there's a lot of research in making predictions of tokens, let's say 4 at a time. And that would drastically reduce how LLMs will behave. So generally, there's a lot of research in making these models run on smaller constrained resources. And I feel like we are kind of preparing for how that ecosystem would look like. And I've talked to Mark to see if we can have another talk. So basically, we want to try and test all of these theories. Again, they're all theories, right? So we are trying to actually get them working, have like a prototype. And then hopefully maybe September or October. Sam is here as well. He may probably do that talk. So this is the team so far. Sam is basically working on optimization. This one helps with, the idea is that we want to change how app design, like how you build apps. So maybe we get some apps that have like agentic capabilities and then store them on Jarvis and figure out how that works. And Gerald is helping with security and guardrails. Guardrails are very important because although we want it to be autonomous, we want the user to be in the loop. So if it's doing something, it doesn't continue without the user's approval. So yeah, that's the end of talk.